Okay, so we're in chapter 17. We're going to be talking about electricity. It won't take too long. We don't have too many notes to go through here. But the first thing is an electric circuit. And an electric circuit is a set of electrical components connected such that they provide one or more complete paths for the movement of charges. There's different types of circuits, a series circuit and a parallel circuit, and we will go over those in more detail here shortly. A schematic diagram, that's a graphical representation of a circuit that uses lines to represent wires and different symbols to represent components. So you'll see a couple pictures of a schematic diagram as well here shortly. A lot of times you see light bulbs or resistors, batteries, switches, things like that to show how the electric current is flowing through the different electrical things that are in a home or in a building or things like that. A series circuit. This is a circuit in which the parts are joined one after another such that the current in each part is the same. So a lot of times Christmas lights used to be circuited this way in a series circuit. And so what that means with Christmas lights, which a lot of them have changed now, but back in the day with Christmas lights, if one went out, then they all went out. So again, with that series, it's just one flow, and once something breaks in it, then that's it, and that flow of electricity stops. A parallel circuit, this is a circuit in which the parts are joined in branches such that the potential difference across each part is the same. So in a parallel circuit, you see lots of different branches. If the light bulb goes out, then everything doesn't go out. It stays that way. A lot of your homes, you're going to see more parallel circuits than you are series circuits. As you know, you're in school or at your house, if a light burns out, not every light in that room goes out or on that circuit goes out. Same thing like in our classroom. If one of the light bulbs goes out, the rest of the lights still stay on. So here we have series or parallel. So what you're going to want to look at then is, looking at the lines that are drawn here and seeing how the electric current actually flows. So if the arrow is electric current and it's going through, it can actually go to two different paths. It can go through that light and it can go through this light. Okay. And so if one of these lights burns out, for instance, like that one, this other light bulb here will stay lit and it can still light whatever room it is. So therefore this one then is called a parallel circuit. Okay. And then the other picture, that's going to be then a diagram of a series circuit. And the reason then that we know that it's series is because it's just one path and then going all the way around. And if one light bulb goes out, then they both go out. And that's it. Then the whole room would be dark or whatever else this may be. So Ohm's law, this is calculating a conductor's resistance, indicating how much the motion of charges within it is resisted because of the collision. So here is going to be the equation that we use to calculate Ohm's law. So the equation is resistance equals voltage over current. So current is going to be measured in amps or amperes, and we do that with labeling A. And then voltage is volts or V. And resistance is ohms, and it's that Greek letter omega. So resistance equals voltage divided by current. And then we have our helper triangle, which is something you might want to write down because you're going to have some practice problems to calculate here. So we have the resistance in the bottom corner, voltage, and then the current. So you'll probably want to write down that helper triangle to help you with calculating these problems, and we'll do more calculations with Ohm's law as well. This concludes our notes over chapter 17, and now you'll need to work on some practice problems for Ohm's law.